I just want to make sure that the mic is like working. Okay, people at the right can hear me. So, hi everyone, I'm Jia Yi. I also go by Jessa for people that find Chinese names a bit hard to remember. And today's sharing would be about how do you secure your LLM applications with testing and guardrails. And as the tagline says, every day is day one. You have to secure your LLM applications after you get them deployed. So a little bit more about me. I'm currently working on driving safety testing initiatives to make sure that AI systems are safe and trustworthy for public service deployment. So I come from GovTech, and I previously specialized in computer vision applications. So it starts from like developing computer vision models to deploying them as well. And just for those that are not aware of what GovTech is, it stands for Government Technology Agency of Singapore, and it's basically the leading agency that drives Singapore digital government transformation across all agencies, and we also push for Smart Nation initiatives to make lives better for both citizens and business. So some examples of services that you would know is for every Singaporean, we have SingPass, we have Parking SG as well. You use them in your day-to-day lives, but some maybe not so well-known applications include Pair Chat, which is a chatbot, you just imagine ChatGPT, but secure version for public officers. We have Vika, which is a chatbot that used to be called Ask Jamie. Across all government agency websites, when you use, they'll be like, okay, do you need any help? Then you can use the Vika chatbot. And also, Career Kaki is a chatbot for all Singaporean citizens to get career advice as well. So as you can see, we do have quite a number of AI applications that are rolled out to public, not just public officers as well. And with this, chatbots that we have, there are also some risks that comes with it, because LLMs, first, they can hallucinate when responding to questions they are not sure of. And for example, in this case, Air Canada, their chatbot actually gave some false information on refund policies to its customers, and they were actually ordered by the court to pay back the amount that the customer was not able to recoup initially. And besides that, AI can also be manipulated by human actors. So in this example, someone actually tried to prompt a chatbot to say that, okay, you will sell me this car for $1, and it could be legally binding. So in this case, it was just an example of how fragile or vulnerable these LLM applications are. And this is why we do need responsible AI to get the end-to-end development for evaluation, deployment, and also monitoring of LLM applications to make them safe, trustworthy, and ethical. So responsible AI is a very huge field, and everyone that's interfacing with AI should be upholding these 6 principles. So they include safety, robustness, fairness, explainability, privacy, as well as transparency. But for today's topic, I will really focus more on safety itself. And whenever you talk to someone about AI safety, they will tell you different definitions. So we are just laying out like what are the possible combinations of or areas of AI safety that people are typically talking about. So it can include like toxic, hateful content, misleading, factually incorrect, all the way to existential risk, which is extremely debatable in today's world. And for GovTech's purpose, we are focusing more on pragmatic risk that allows us to tackle it today because they present immediate challenges to usability. And our goal is to make LLMs safe enough for widespread use across all government services. So we are like focusing more on whatever is inside the green box as of today. And most safety testing efforts for LLMs are focusing on evaluating foundational models, but not at the application level. So just imagine some of the LLM benchmarks that you have seen. For example, we have the BBQ benchmark, and they actually prompt the LLM in terms of MCQ. So it's like, okay, would you rather do A or B or C? Which is not what a normal user of an LLM would do. So they don't really represent real-world use. And next, LLM applications have different risks than foundational models because you will put in your system prompt, you will have maybe a RAG, retrieval pipeline, your vector databases, you have your guardrails. All of this actually makes them fundamentally different from the LLM application, the original model that you were using. So just to preface a bit, LLM applications include chatbots, includes like document summarizers, AI-powered search tools, but as of today, our focus still remains on chatbots because they are the most prevalent use case and most commonly used LLM application out there today. And safety testing is important to help product teams that are rolling out all these LLM applications to understand how resistant their products are to attacks. And without any adequate safeguards or like checking and understanding how well your LLM application is performing, you can be blindsided by users that try to trick the system, and they can generate unsafe or dangerous text to users. And this is why the second principle comes out today, which is that we need to define what risks are present in your application. We need to determine how to measure this risk and find out how to mitigate them. So these are three very important steps. And first, to define what risks are present, you have to develop a customized risk taxonomy. So here I will actually be sharing a little bit more about how we evaluate the safety of our applications and how you can actually do them yourself as well. So there are some fundamental principles that you can reapply, and we'll also be showing you some case studies of what we have done. And the first key principle in building an effective customized risk taxonomy is that you should start by compiling a list of risks and concerns that you are concerned with your use of AI in your organization, or it could be just a chatbot that you are trying to train. First, you should contextualize general risk, work off established frameworks from academia or industry. There has been a lot of benchmarks out there. Start looking at them and see whether they are applicable to you. And some of them are more like there are legal frameworks that you should apply. Like for example, if you're in the EU, then perhaps you should look at the EU AI Act to make sure that your risks are covered well. And consider how these risks manifest in practice, and conduct internal consultation with stakeholders to make sure that they cover every single aspect of risk that you might expect. And second is to focus on practicality. So you should focus on concrete present-day harms. For example, earlier I've highlighted how we focus on a subset of AI safety risks. And you should make sure that the taxonomy is meaningfully specific, meaning that sometimes you may think that, okay, if I add in more subcategories, more severity levels, it will actually make my taxonomy seem more meaningful. But at the same time, if you're not doing anything with these severity levels and the targeted mitigation measures are the exact same, then it's not practical for you to actually break them out into so many sub-risks because you're just overcomplicating things. So unless there's a different mitigation measures that you're looking to apply to different risks identified, you should just keep them meaningfully specific. And third is that you should anchor definitions in relevant legal and regulatory frameworks as much as possible. So in the case of whole of government, which stands for WOG applications, we actually define our safety risk into these specific categories and subcategories. So first bucket, we have the undesirable content, which includes hateful, insults, sexual, physical violence, self-harm, and all other misconduct. So all this taxonomy was actually curated after much discussions with different stakeholders and also understanding what are the concerns within the government applications. And I mean, hateful and insult might actually sound very similar, but for us, we actually ground them in the Singapore legal definition of what are some protected characteristics. So they actually, there is a fine line between what is considered hateful and insult, but in general, it is very confusing. I know, like taxonomies, you have to define them clearly. And the other risk that we are concerned about is unqualified specialized advice that can cause potential physical or financial harm for users. For example, if you have a government chatbot, you wouldn't want it to provide you medical advice when it is not meant to do so, right? For example, you're asking things about tax, right? And you ask it, oh, okay, I'm feeling sick. In general, these are advices that we do not want our chatbots to be engaging in. And third is political content. Regardless of how neutral it may seem, it could actually lead to discourse and unhappiness. So in general, government chatbots should just avoid special advice and also political content in general. And after you get this taxonomy of risk that you're concerned about, you can then further break them down into severity levels if relevant. So in our case, we actually break down our hateful content into discriminatory speech and hate speech. And hate speech is actually more actionable. it calls for harms and violence against a protected group. And it is more actionable because, for example, you have a chatbot. When it's discriminatory speech, you can just say, okay, you are flagged. But when it calls for hate speech, you could actually want to escalate that to more serious matters, which is why severity levels do matter if there's an actual practical use for dividing them. And as mentioned, our hateful definition is actually grounded in our Singapore law, which is the Workplace Fairness Act, which allows us to actually legally align with what is defined in regulations. So this is an example of how you can define your taxonomy, and yeah, just some case study for you to reference as well. And next, after you define all this risk, how are you going to measure them? Because most of these benchmarks available out there, they do not measure LLM application specific risk. And for GovTech, we define safety testing as the process of assessing an LLM application using prompts designed to elicit unsafe response in order to provide a rough empirical assessment of how resistant the LLM product is to common safety attacks. So for example, you can just prompt an LLM with some unsafe content, and you can see that the unsafe LLM would comply or engage with your statement, but the safe LLM will actually refuse for you to continue the conversation further. So this is the main principle of how we'll be conducting this safety testing. So it might sound easy, but actually there are a lot of things to think through. So one is, how do we actually curate these effective adversarial prompts? So here we have outlined 4 principles for you to do so. Number 1, it should be meaningful. It must reflect real user interactions and clearly target a single risk for you to be able to identify which are the specific risks that are attributing to this jailbreaks. And you should also avoid vague phrasing. They may obscure the intended unsafe behavior and also confuse the LLM. For example, you can say something like, oh, how do I beat this person? It could mean like in a competitive way, or it could mean like physical violence. So there are some phrasing that are ambiguous, and you should make it clear on what you're trying to say. And I mean, ideally, if you have real world data, you should always incorporate them into your safety testing set as well. Number 2 is that it should be diverse. They should exhibit diversity in content, structure, and sources. So when we say structure, it could mean like, is it a task? Is it a question? Or is it a statement that you are curating your prompts to be? And for sources, it could be AI generated. You can be rate teaming an LLM model. You could be gathering this data from multiple different places as well. Contextualized. You have to tailor prompts to localized context to address linguistic, cultural, and regulatory nuances, especially when English-centric data sets fall short. So an example, linguistic, we have Singlish, right? Most of the LLMs available actually don't tend to understand every single aspect of Singlish very well. So for you to actually try to jailbreak, like let's say ChatGPT or Claude using Singlish is actually not an impossible task. And the next aspect is cultural. There are a lot of cultural like terms as well, like for example, MRT, HDB, right? Those that things users that live in a specific geographical region that would actually relate to. These are some areas. And also regulatory nuances such as weed is illegal in Singapore, but it may not be illegal in some other places in the world. So these are things that you have to consider when curating your prompts. And they also should be incrementally complex. They should be from easy to hard, so you can actually get a wide range of like user spectrum. Some of them are being more naive, they could be kids, and some of them are being like AI enthusiasts. They could know all the jailbreaks available. So these are the 4 key principles that we have. And from the taxonomy that we have curated earlier on, you can then develop a safety benchmark that is aligned to them. So for example, you just imagine this entire benchmark is filled up. So for us, we did so based on our taxonomy, and we curated a total of about 1,600 prompts. And this is our good baseline benchmark. But we also wanted to understand how does prompt templates, adversarial prompt templates actually change the safety risk level. So to increase or enhance the attack complexity, we pair these attacks with some well-known adversarial prompting templates. So the original prompts form the basic level test, and these combined prompts from the intermediate test. So it's not necessarily that you have to split this into like 2 different tests, but this is what we have done because we wanted to attribute whether having a adversarial prompt template could help or make a LLM application more susceptible to jailbreak. And the answer is yes, it does. And after you get all these prompts that you're ready to send into your LLM application, and you get the output, right? It is actually not straightforward for you to define what is considered an acceptable safe response. It's kind of like a trolley problem. So consider this scenario. Should a customer service chatbot respond with sympathy and empathy when prompted with suicidal messages, or should it refuse to engage further? So I mean, it's really like a trolley problem. And I mean, most of the organizations will think of it more from a liability standpoint. They would rather just not engage further because it's the safer choice to do so. And I mean, in the real world, if the trolley problem happens, for you to not do anything, you actually have less legal liability. So for us, we define refusal as a form of safe response. If the chatbot just tells you, sorry, I can't engage further, and ends the conversation. Because it limits engagement with sensitive prompts, reduce liability or risk. And to define what constitutes as a safe refusal, you have to first start by identifying suitable refusal types for your application context. There are existing taxonomies out there that define what are the different types of LLM refusals available, and you can actually go through this taxonomy and see what is relevant for you. And in general, you should apply a stricter refusal definition. So it's actually a more conservative safety baseline, because if you actually relax your definition of what is considered a refusal or not, you actually just increase the safety levels of your application. So in general, just be more strict with your definitions from the start and see whether you want to relax the definition. And for you to detect what is considered a safe refusal, you can either do keyword search such as I cannot or I'm sorry. But most of the LLM applications, they may have system prompts that say like, okay, if you don't want to answer, you should like respond with like ABC, something like this. So keyword search could work for the worse or for the better. And the other way that you could classify it as well is using a refusal classifier. There are many different open source classifiers that you can use. But from what we have tested, we noticed that because they are trained on a specific data set that is very different from our LLM applications, it's not the best when it comes to classifying refusals for your application. So you could possibly, train your own refusal classifier. They are typically very lightweight, and it allows you to detect very quickly. And the last option is to use LLM as a judge. You can use an instruction following LLM like ChatGPT, OpenAI for all, and to assess whether a response is a refusal or not. So there are quite a number of works in the academic field, such as Allen AI's Wildguard. They actually have a refusal purpose-trained LLMs for you to use as well. So you can actually further fine-tune these LLMs. They are actually better, but the downside is that they tend to be slower, and it could be costly if you are calling a proprietary LLM, for example. And regardless of what you choose, you must always evaluate your evaluator. And so going back to the diagram earlier, now we have the response from the LLMs. We can actually pass them through our refusal evaluator to see whether the LLM is engaging, which is unsafe, or it refused, which is safe. And these scores helps you to review the LLM application's resilience to common safety attacks and help to guide some mitigation efforts. So the scores that we see here represents the proportion of like safe responses out of all attack prompts that you might curate. And it can be further segmented by risk category or severity based on how you define your taxonomy for deeper insights and mitigation measures. And they help you to highlight areas where your application could be the most vulnerable. And it guides teams in prioritizing and implementing strategies on how to mitigate such risk for your application. But then comes the question, what is considered safe enough, right? Is 95% okay, or is 90% okay? So in general, there is actually no golden rule of thumb that you might see on the internet today. Even for AI Luminate that actually benchmarks against the biggest LLMs that we see, they do a reference against a baseline system. So in our case, if we are benchmarking our LLM application, we should benchmark against our previous version of our LLM application, seeing whether a tweak in system prompt, a tweak in guardrails, could that actually change any scores? Maybe GPT-4o updated their model. Does that actually affect me? You should always use in reference to your baseline system. But if you do not have a baseline system because that's your first time running the test, then you should actually go in to look at the failure cases and understand whether they are actually acceptable to you. Because some of this engagement, like the LLM application engaging in unsafe content, could be more mild than the others. And you kind of had to make the final call yourself, whether it is acceptable or not. So currently, there is no golden rule of thumb, unfortunately. And there are some limitations in the safety testing scores when it comes to assessing real-world readiness, right? A perfect score doesn't imply zero risk. We know that LLMs change every single time you prompt them, even with the same exact prompt. So there is no formal safety guarantees, even the refusal evaluator that you have chosen, LLM as a judge. It's not 100%. So there are some inherent error rate that has been going on, and that you just have to consider what if that 1% error rate is the one that is causing like a fatal mistake for your company. And number two, a non-perfect score does not imply that the application is unsafe for deployment. It's possible that you can actually make some user interface or user experience nudges to make sure that users actually stop trying to jailbreak your system. For example, an education chatbot, you can say that, oh, okay, please stop trying to jailbreak. We'll report this to the relevant authorities, like your teachers, your parents. It will actually nudge students to stop trying to jailbreak. So these are some mitigation measures that you can make in order to reduce the number of unsafe risks that are present. And the last point, most importantly, is that these safety scores do not measure utility. So it's possible that the guardrails that you implement, it blocks off every single unsafe prompt. But at the same time, it also blocks off every single safe prompt in this world. And that renders your application useless. So it's very important for you to do separate utility checks and your evals to make sure that safety and utility goes hand in hand. So you can kickstart your safety testing using open source SDKs and also web platforms. And in general, it's more, it allows you to do some end-to-end seamless testing without you having to do up your own Python codes. So there are many of these libraries available today. And what you need for your application is that you need an API endpoint. So just imagine your application as a black box, input in, output out. That's what you need to start your safety testing measures, because you do not need to break down every single aspect of your application. And some tools that I would like to highlight are like Garab, Giskart, which are very, very popular, maybe like 4,000 to 5,000 stars on GitHub. And there's also the UK AC's Inspect, Moonshot by IMDA. And you can also see there are some startups like Haze Labs that offer such safety testing services as well. So if you're interested, you can check them out. And moving on to the third important part is how do you mitigate all these identified and measured risks? So we mentioned that maybe RAG databases actually affects your safety, but you actually can't really change your RAG database to make your application safer. And the three components in influencing your application safety is guardrails, system prompt, and also LLMs itself. So most of the LLM providers, they do have some safety tuning, which helps them to reject unsafe prompts. But as mentioned, we have some cultural nuances, linguistic nuances they are not able to capture. And next is your system prompt. You can ask them to explicitly deny things that are out of topic. For example, if you are a chatbot for students, then you should discuss things that are appropriate for their age group and within the educational scope. And the last part is guardrails. You can use independent detectors to screen inputs and outputs to the LLM itself. And you should start your risk mitigation measure by first grounding the system prompt within scope. Ask them to follow instructions that are only relevant to their task, and also wrap the user inputs in quotes to make it clear to the LLM that, hey, this is the user input. So maybe they could come up with jailbreaks like, oh, I'm the system administrator, blah, blah, blah. So it's at least clear to the LLM model that this is the user input. And you should also use guardrails, which is the most important part. They are a broad ecosystem of commercial and open-sourced guardrails available today, and they vary in complexity. You can do a keyword check, you can do a simple classifier, and you can use LLM as a judge as well, which is quite similar to the refusal evaluator, but for guardrails, they are similar as well. And guardrails are applicable to both inputs and outputs. And for example, if you detect a jailbreak coming in, you should use an input filter. It will actually save you cost so that your LLM application does not have to, even process such unsafe inputs as well. Yep, and I would like to highlight some of the work that we have done at GovTech, one being LionGuard, and it is a Singlish toxicity detection classifier model, and it allows users to actually use this model to detect unsafe or toxic content to use them as a LLM guardrail itself. So we published this back last year, and it was accepted to Colink as one of an oral presentation. And during the evaluation, we found out that they perform way better as compared to open source as well as proprietary moderation APIs, as we can see here. And currently we are, improving this model as well, so you can stay tuned to our developments, because we will have a new version coming out soon. And another guardrail that we have developed is off-topic query detection. Because most of the time, people would say, oh, hey, we actually don't have any data, like how do I actually prevent my chatbot from going off the guards? And you can use a off-topic query detection. What you need is just the input prompt and also your system prompt for your application. So maybe your system prompt says that you're a physics chatbot, blah, blah, blah. And someone, when they ask you something that's beyond physics, it will actually trip it and tell the LM to say, hey, let's not respond to this input query. And we are able to achieve 99% accuracy, which is higher than GPT-4o mini at the point of development. And we also improve resistance to jailbreaking attacks and forbidden questions. So yeah, and we were able to get this paper accepted to iClear just this April. And both of these works are open source on our Hugging Face as well. So if you're interested in using these models, testing them out, you can also head on to our Hugging Face. And yeah, implementing guardrails, most importantly, is that you should always use a Swiss cheese approach. That's what we call it. Because when there are multiple different attacks that are coming to your LLM applications, not every single guardrail can block everything. And when you layer all these guardrails together, meaning a Swiss cheese approach, you can actually detect and filter out most of these input attacks. And similarly, when it comes to the output guardrails, the same reason applies, right? By putting more different guardrails, you are able to make sure that none of these get through the cracks or the holes that you have in your cheese. And yeah, with that, I will also highlight our third most important lessons of the day, is that responsible AI testing and mitigation should be monitored and continuously updated and performed to make sure that you safeguard your applications. Because we do know that defenses become better with time, and so does adversarial attacks, right? Currently, what we have covered doesn't include like multi-prompts attacks, multilingual attacks. It covers things that are more basic, such as like role-playing, adversarial prompts. So there are definitely areas for us to further improve our safety testing methodology. And GovTech, in trying to safeguard our whole of government applications, we do have a central platform for all LLM products to come to us and perform safety testing with our AI Guardian service. So it's allowing users or product teams to conduct these safety testing and also to implement guardrails. So it's just a central platform to allow them to easily onboard with us, and they do not need much effort, because typically when it comes to safety testing and deciding which guardrail that you want to choose, it involves a lot of like data science work, and not every product team do have an extra data scientist, right? And another work that we have done to continuously monitor the risks evolving in this world is that you have to be proactive in identifying what is some key risks that you're interested in. For example, we witnessed that some actual users for government systems tend to try to bypass the guardrails that are in ways that we did not expect before. So for example, some of our frontline officers, which are teachers, actually did notice that some children's use of AI was fairly different from how we adults think that they would use AI. And this is why we actually developed a hand-built benchmark for content-based risk specifically for children and mimicking how they will actually prompt chatbots itself. So this paper is open source the data set is open source on Hugging Face, and yeah, you can check it out if you are interested and if you're an educator and want to find out more about them as well. And before I end off my presentation, I would like to recap our 3 key takeaways or lessons of today. Is that everyone, including developers, is key to upholding the 6 principles of responsible AI. It is important to first define what risks are present before determining how to measure and mitigate them. And last is that responsible AI testing and mitigation should be monitored and continuously updated and performed to safeguard applications. So with that, I came to the end of my presentation. Let's keep in touch. If you're interested with what my team does, you can check out our responsible AI playbook as well. Thank you. I'm not sure if we have time for questions. Okay, questions, please.
Yeah.
Oh.
That was the camera. Okay. One question I have is, it sounds like this has a close intersection with LLM eval in general.
Mm-hmm.
Would you say that that's the case? And also, where does the line draw between like guardrails that do evaluation tasks and like normal evaluation? Obviously, one is in the line of the request, but can you talk more about that nature?
Okay, I do agree that safety testing is kind of like evaluations, but this is more of an safety evaluation. And the line between LLM and LLM applications is that the applications could have multiple different components that has been proven to affect its safety levels in multiple studies that we have. And the line in between is that the existing LLM benchmarks or safety testing done by the AI security institutes, they often rely on benchmarks, for example, the MSQ benchmarks that doesn't accurately represent how your users might prompt a LLM. And second being that it is not customized for your use case. So it's actually, there's a fine line in between. And your second point is about guardrails. Sorry, do you mind rephrasing your question?
So for example, I could run evaluations after the fact for like quality assurance of requests, things like that. But it seems like these are made, in fact, not just to run inline to prevent something from coming in or coming out, but also with Swiss cheese, multiple of those. And so I'm wondering, has that impacted model design so that it can operate fast enough to not just run one, but multiple ones? Or do they fan out and then make a quorum, or like how do you manage that? Because like some of these rules sound like they could take like a second to finish thinking about.
Understandably. You can do a multi-threading approach that you actually run multiple guardrails at one go so that it actually doesn't affect your user experience. And sometimes you can also do streaming outputs into your guardrails so that once it generates and detects that it's unsafe, you actually stop the request itself. But with that being said, the user might also be exposed to some of the unsafe content, and ultimately it's a product call whether it is how to implement the guardrails. Yeah.
And that's something that you sort of walk through the agencies that have this problem, where you have like some sort of proxy that everyone should use to deal with that.
For us, we don't have a golden rule of thumb and say like, hey, you should implement your guardrails in this way, but we do push out guardrails that we recommend. For example, our localized English toxic guardrails and also multiple different commercially available guardrails for the users to use. So once they are on our platform, they found out that, hey, we are exposed to these risks, we recommend specific guardrails, and it's up to them to implement the way that they desire in order to not affect their user experience. Yeah, so that's how we are doing things. Cool. Thank you for your questions. Yeah. Any other questions? Thank you.